Okay, here we are back for video 2 of Unit 1. The second example is going to be a two-variable stats example. Uh, concern for Miss Craig in renting a handsome cab for prom is that only the rich kids would be interested. Below is a systematic sample of the students buying prom tickets, where the X variable is the family income in thousands of dollars, and Y, the Y value in the table, is how much the student was willing to spend on the handsome cab. Um, Systematic sample, by the way, throw these little definitions in here once in a while, is when we sample somebody, every 10th person gets sampled. That's systematic. Uh, anyway, and if that doesn't sort of come up and make us one approach this question differently, but it's nice to know that in case that's one of the definitions that comes up on the exam. So I've done the plot. Remember, first thing the table goes along the bottom, second thing on the side, and I've done my scatter plot. Now, I think that's question C or something like that. The first question is explain the correlation that Miss Craig is expecting. When she says she's worried that only rich kids would be interested, she thinks that for high incomes are leading to high willingness to spend. So she's expecting a positive, where low incomes, low willingness to spend. That's a positive correlation, right? As one goes up, the other one goes up. So she's thinking higher income families are willing to spend more. So she's expecting a positive correlation. Do a scatter plot and include your guess at a line of best fit. So I've done my scatter plot. I haven't done any breaks in any of the graphs there. As far as the line of best fit is concerned, it's pretty tough when it's spread out like this. But the idea that we sort of helped us with is to try and draw a loop around like a tight band around all the data, and try and figure out a line that would split them roughly in half and follow the trend of the data. Now, this is really tough because there's not really much of a trend at all, is there? So, I don't know. If it's all over the place, I'd be tempted to draw a line straight across there. But, of course, we're going to do this using the calculator, but maybe we'll say it's something like that. Is that about half the data? Well, maybe not, but I could move it something like that. 1, 2, 3, 4. 1, 2, 3, 4. And does it follow the general trend of the data? Well, some of you might say the trend of the data is that there's no trend, but let's go with that, and we'll see what the calculator says in a second. It says complete a least squares regression to calculate the equation of the line of best fit, state the correlation coefficient. Okay, well, how do we do this? Well, we fire up the TI-83. And notice I've still got all my data from before in there. So what I'm going to do, remember you press clear and then enter to get rid of that. Clear and enter, and then you start putting the data in. I'm going to pause my video to put the data in, and you can do the same. Hopefully you're following along somehow. All right, bam, there's my data. I put that all in there, and then how we get it to actually come up with the good stuff is to run linear regression, right? So that's under Stat Calc menu again, Stat Calc, and then I go down to linear regression. The defaults, remember, are list 1 and list 2, and that's where our data is. So I'm just going to press enter, and then it comes up with a line of best fit, right? It says, and I'm going to maybe copy that. Paste that on there. There's the equation of the line of best fit. Y equals 0.93-ish, x minus 17.7. And then it says state the correlation coefficient. And if you remember, usually there's a couple more things here, right? It says R and I, and there's big, and that was the correlation coefficient and the coefficient of determination that tells us how good this model fit our data, and it just ain't there. Now, do you remember where it came from, or where that was? Well, there was a setting on the calculator that we have to turn on. And if you've just replaced the batteries, or you haven't done this on a calculator before, it's the default is to have it shut off. So you might have to do this again, and I'm going to. Every time I turn this one on, in fact, I have to do it. So then I went second, 0 to get to the catalog menu, and then I got to go all the way down to diagnostics on. Hopefully I remember this. Diagnostics on. Run that command, and then I got to go back and do my linear regression again. And remember, when we did curves of best fit, those were those other ones. Quadratic regression for a parabola and so on. Okay, so I've got R equals 0.43-ish about. I won't worry about R squared. So what does that mean? An R value of 0.43 is a moderate positive relationship. Moderate. Let's go again there. Moderate positive relationship. So what does that mean? Well, that basically says that R is 0.43, but what does that tell me about income? Well, what that says is as income increases, so does the willingness to spend. So as income increases, the willingness to spend, I'm just going to do a short form here, also increases. How do I know that? It's because the R value is positive, the slope of the line of best fit is positive, and guess what? Miss Craig was right. All right, that's it for this video. Next one is counting.